I'm Anil Kumar. Welcome to my series on complex numbers. Here is part 2 of our complex numbers. We'll discuss solution of question number 8 to 13. I'd like you to pause the video, copy these questions, answer them, and then look into my suggestions. So let's begin with question number 8, which is very much related with question number 9. Question number 8 here is expand z minus alpha times z minus beta, and 9 is find the equation whose roots are 3 plus 4i and 3 minus 4i. So let's answer question number 8 first. Expand z minus alpha times z minus beta. So when you expand, you get z square minus beta z minus alpha z and the product of these two, so plus alpha and beta. So that gives you z square minus, taking z common, you get alpha plus beta. I've rearranged them, right? Plus alpha times beta. So here, what you learn is that if alpha and beta are roots, then the equation could be written as z squared minus sum of roots times z plus product of roots. Is that clear? So that is how you would actually write the quadratic form of the equation knowing the roots. Now question number 9 is we are given the roots, right? So the two roots, let's call them as alpha and beta. So alpha is 3 plus 4i and beta is 3 minus 4i. Now these roots are conjugate roots. We need to find the quadratic equation with these roots. So we can write that the quadratic equation will be written as, since these are the roots, we can write this as z square minus sum. So what is sum of roots? Alpha plus beta is 3 plus 3, right? So which is 6. Sum of roots with a negative sign, right? Plus the product of roots. Now how do you find the product of roots? The product of roots is basically a square plus b square. That is the product of roots, right? So the product root is 3 square plus 4 square equals to 0. That will be your equation. Correct? So you get your equation as z square minus 6z plus 9 plus 16 is 25 equals to 0. Correct? So that is how you could actually get your equation. Now what it did here was we did alpha plus beta as equal to 3 plus 4i plus 3 minus 4i, right, which is 6, right? That is the sum of roots. And we wrote alpha times beta as 3 plus 4i times 3 minus 4i, which is equals to 3 times 3, a square minus b square, right, minus 4i whole square, right, which is 9 plus 16 equals to 25. Is that clear to you? So that will help you to understand how we kind of related first and the second question and wrote our equation. So if we qualify with the word roots, that means all this is equal to 0, right? And therefore, we get that equation. Is that clear? Now let's look into question number 10. Question number 10 is to expand and simplify 2 plus 3i cube. So let's do it. We get 2 plus 3i whole cube. So we could write this as 2 plus 3i square times 2 plus 3i, right? So a square is a square, which is 4, 2ab plus 4 times 3 is 12, 12i, plus b square, which is 9i square, right, which is 9i square, times 2 plus 3i, correct? Now, I square is negative 1. So we get this as 4 plus 12i minus 9 times 2 plus 3i. So clearly, let's simplify this first. So we get 12i minus 5 times 2 plus 3i. And now we can apply the distributive property. Multiplying by 12i first, we get 24i, and that gives me 12 times 3 is 36 I square. Then with negative 1, we get negative 10, and negative 5 times 3, negative 15i. Combining the like terms, well, this is negative. Let's go one more step. So 24i minus 36 minus 10 minus 15i. So what we get here is 36 minus 10 is minus 46, and 24 take away minus 15 means 9, right? So we get plus 9i. So that becomes the result of cube of 2 plus 3i, right? You can also say that the cube root of this is that. Perfect. So we could also say, so you can try this out, do the reverse. So check. That is cube root of minus 46 plus 9i is 2 plus 3i. Correct? So you could correlate in this fashion. Now let's take up the next example, which is question number 11. You need to evaluate I to the power of 99. I'd like you to pause the video, answer this question, and then look into my suggestions. We need to evaluate I to the power of 99. Now let's look into a few properties to solve this particular question, right? So let me just share with you that on a coordinate plane, we could represent real numbers on this side and imaginary numbers on the y-axis. So when I say I, so I is this, right? That is I, imaginary. And then this is I square. And this is I cube. And that is I to the power of 4, right? So as you multiply, it kind of circulates. It's like a circular function. So what I'm trying to say here is that I to the power of 0 is 1. I to the power of 1 is I square is minus 1. I cube is minus 1 times I, which is minus I. And I to the power of 4 is 1. Then if I do I to the power of 5, I multiply this with I, right? So I to the power of 6 is I square, which is minus 1. I to the power of 7 is minus I, and I to the power of 8 is again 1. So what you really find here is that there is a pattern, right? So the pattern to be noted here is that the number repeats. Do you see that? So if it is a multiple of 4, then we get 1, right? So what you realize here is that I to the power of 4n is equal to 1. You see the point. Correct? So, if it is a multiple of 4, you get 1 as your result. That is very important to understand. Now, we can always use this particular property to find our function. Perfect? Now, these are the remainders when you divide by 4. Those are the remainders, correct? So I to the power of 4n plus 1 is basically I. So I to the power of 4n plus 2 is minus 1, and I to the power of 4n plus 3 is minus I. Do you see a pattern here? Now you can use this pattern to find any powers of I, right? So use pattern rule. To evaluate exponents of I. Is that clear? So in our question, we need to find what is I to the power of 99, correct? Now I to the power of 99 can be written as I to the power of 96 plus 3, right? Why do I write 96? 96 is a product of 4, right? Let me show you on the side. So if I have 99, and if I divide 99 by 4, what do I get? 4 times 2 is 8, right? Then we get 19. And 4 times 4 is 16. The remainder is 3. So basically, we could write I to the power of 99 as I to the power of 24 times 4, right? So 4 times 24 plus 3. Now the first part here is just 1, which is I to the power of 4 times 24, which is 1, times I to the power of 3, right? That is the meaning. So what we get here is I cube, and the value of I cube is minus I. So our answer is minus 1. Is that clear to you, right? So we can write down that the value of I to the power of 99 is equal to minus 1. Is that clear? So we use the function mod 4 also to evaluate these results. Perfect. I hope this concept is absolutely clear. And also we'll be using this particular concept that the value of I, when multiplied by itself, moves counterclockwise on a plane to give you the value. I hope that makes sense. Now let's look into the next question, which is question number 12. Question here is, if z equals to 2 minus 3i and w equals to 1 plus 2i, find z times the conjugate of w minus w times conjugate of z. So let's write down what we are given. So we are given z as equals to 2 minus 3i. The conjugate of z is 2 plus 3i. We are given w as 1 plus 2i, and the conjugate of w is 1 minus 2i. We need to find the product. Z w conjugate minus w z conjugate, correct? So we have 2 minus 3i times the conjugate is 1 minus 2i minus w is given to us as 1 plus 2i times the conjugate of z, which is 2 plus 3i. Is that clear, right? So that is what. So let's expand and simplify. So we get 2 times 1 as 2. 2 times this is minus 4i. With negative 3i, we get negative 3i. And that when you multiply, I square makes it negative, so we get negative 6. Now here, let's put them in brackets. With 1, when you multiply, you get the same numbers, 2 plus 3i. And with 2i, you get 4i, and then that becomes negative sign. 2 times 3 is 6. So let's combine the terms. 2 minus 6 is minus 4, and that is minus 7i, minus, within brackets we have 2 minus 6 is minus 4, and that is plus 7i. So basically what we have here is minus 4 minus 7i, change the sign, plus 4 minus 7i. And minus 4 plus 4 is 0, and we get minus 14i as our result. Is that clear to you? So that is the result of the given expression. Now here is the last question for us. This is kind of a bonus question for you. You can pause the video, answer this question, and then look into my suggestions. We have a very interesting question here, which is 8 plus 6i is equals to a plus bi whole square. Find a and b. I'd like you to pause the video, answer the question, and then look into my suggestions. Now, whenever we have two equal complex numbers, then we need to equate the real and the imaginary part. Okay, so let me rewrite this as 8 plus 6i equals to a plus bi whole square. So what we get here is the right hand side, a plus bi whole square, will be a square plus 2 times a times bi plus bi whole square, right? That's what we get. And this will give you a square plus 2abi, and this is minus b square. So we get the real part as a square minus b square, and the complex part as 2abi. Is that clear to you? Now, when they are equal, we have to equate the real and the imaginary parts, right? So the real parts and the imaginary parts, correct? They should be equal. So we get two equations. 8 is equal to a square minus b square, and 6i is equal to 2abi. Correct? So we get two different equations to solve. Now from here, from the second equation, we can write a in terms of b, right? So we could write this as, we can write b as equal to 6 over 2 or 3 over a, right? So when you divide, I and I cancel, 2 goes 3 times and a comes in the denominator. So b equals to 3 over a. Substituting b equals to 3 over a in our first equation, we should be in a position to solve, right? Let's say this is equation 1 and that is equation 3 for us. We'll term this as equation 2. Now let's try to solve. So what we have here is 8 equals to a square minus b square, and b is 3 over a. So we have 8 equals to a square minus 3 over a whole square. So 8 equals to a square minus 9 over a square. Multiplying with a square, we get 8a square equals to a to the power of 4 minus 9. So we do get a quadratic equation. To solve this, let's bring all the terms together. So we get a to the power of 4 minus 8a square minus 9 equals to 0. Now, we can do product and sum. So 9 times 1 is 8. So we could get this as a square minus 9 times a square plus 1, right? So that should be fine. So that gives us two solutions. One of the solutions from here is that a square equals to 9, and here we have a square equals to minus 1, so which is not possible. A and B are real, right? So note that both A and B are real. A and B belongs to real numbers, okay? So we cannot have this complex number. So we get A as equals to plus minus square root of 9, which is plus minus 3. So we have the value of A as plus minus 3, and the value of B is 3 over A, right? So from here, we get the value of B as plus minus 3 over 3, which is plus minus 1, correct? So we get the value for B as well as for A, depending on if it is plus B, we got plus 1, right? So both positive or both negative. So keeping that in view, we can now write down that 8, so those are the two solutions, correct? So with those solutions, we can write 8 plus 6i could be equal to, so A could be equal to 3 and B is 1, right? So it is equals to 3 plus 1i, let's write I here, whole square, right? And this is also equal to minus 3 minus 1, right? So this is, or we have minus 3 minus I whole square, either way. So we can write 8 plus 6i as 3 plus I whole square, basically, right? That is one and the same thing. So that is how we can find the value of A and B. So we get our answer that A equals to 3, then B equals to 1, and if A equals to minus 3, then B equals to minus 1. Is that clear to you? So I hope that makes sense. With that, we come to an end of our introduction to complex numbers. I hope you have understood and enjoyed this process. You will also note that in the last example, we actually found square root of 8 plus 6i. If you rearrange this, right, so you could see this as also square root of 8 plus 6i was equal to plus minus 3 plus I. Does make sense to you? So we did find square root also, and this is a good method to find square root of a complex number. So I hope that makes sense. So with that, we come to an end of our introduction to complex numbers. I hope it really helps to understand the topic. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.